Okay, now we're recording. All right, here we go. Correlation coefficient. There's an interpretation. Remember, when we do a linear regression, you get a correlation coefficient. And it's a number, and R is the variable for it, between -1 and 1. And depending on how close the R is to a -1 or 1, will tell you whether there's a correlation or not, right? If it's a number in between -0.5 and 0.5, there's no correlation. If we have a number in between +0.5 and +0.75 or -0.5 and -0.75, it's a weak correlation. And the closer it is to 1, the stronger the correlation. So bigger than 0.75 to 1 or smaller than -0.75 to 1 gives you a strong correlation. Of course, the correlation for a positive number is a positive slope, and with a negative number, it's a negative slope. So line of best fit has a correlation coefficient. Oh, so this is a very strong negative correlation. What can you conclude about it? The slope is 0, the slope is positive. No, the slope is definitely negative. Right? It doesn't tell you what the slope is. It just tells you if the points actually line up or not. So here's more information. We've got basic equations of lines and the interpretation of the slope. For every 1 increase for the x value, the y is expected to increase or decrease if the slope's negative by the amount of the slope. So when x goes up 1, the y value will go up the amount of the slope. So use the graph to write the equation of the line. Remember, the equation of the line typically is y equals mx plus b, where b is the y-intercept. And you can look at the line and you can see it crosses the y-axis at 0. So in this case, b is 0. So our equation y equals mx, and m is the slope, rise over run. And you can reduce that fraction to 3/2. So 3/2. Okay. And that's the equation of the line, y equals 3/2 x. Now interpret the slope. And remember, it says for each additional, in this case, years, each additional year, the height of the tree is going to go up 1.5 feet. The height of the tree, the height increases 1.5 feet each year. So that's exactly that one. All right. So here are the steps to do a linear regression on your calculator. Okay. And I'll refer to these in a little bit. So if we have this for our data, we can plug these data into our calculator and figure out the linear regression. So where you do that is under Stat. You press the Stat button, and you press Enter for Edit. And then you can put the X numbers, 9, 13, 18, 22. Um, 23 in for the X values, and then the Y values in for the Y part. 3, 5, 7, 10, 11. 3, 5, 7, 10, 11. 3, 5, 7, 10, 11, 9, 13, 18, 22, 23. Okay, so it looks like I have them in. Remember, this says go to Stat and then Edit. We're going to press Y equals and highlight plot 1. And then we're going to go back to Stat, calculate 4. So go to Y equals, highlight plot 1. You can clear anything you have for these. Then we're going to go to Stat, Calc, 4, linear regression. And we're going to calculate. And there's a linear regression right there. Y equals 0.55, it's actually 0.56, x minus 2.76. Y equals 0.56, x minus 2.76. What? 2.26. Okay, that changes things. 2.6. And looks like this is the closest one, so we choose that one. All right, it doesn't look like they rounded correctly, but oh well. If there's a linear relationship, and interpret the meaning of context. Okay, so we need to figure out what y is when x is 15 using this line of best fit. Okay? So we can do that pretty easily. We'll just plug 0.55x minus 2.25, 0.55x minus 2.25 into it. And then if you go to the table, we can plug 15 in. Well, yours is probably set up so that it automatically puts numbers in. We just have to go down to 15. And when x is 15, y is 6. Y is 6, which means after 15 months, the hair will be 6 inches in length. Okay? Because when the x value is 15, the y value is 6. So 15 months, 6 inches in length. Okay? I don't think I can get through these next two in the time I need. So I'm going to stop here. Maybe I'll try. I'll do it. These two, we're putting the data in. This is the 0.1213, 23, 24, 34, 35. And 4, 5. So put those values in to your calculator. Looks like we're looking for the line of best fit, and we're trying to find the correlation and interpret the correlation. So we do have a little bit to do. Under Stat, Edit, we're entering these values, 1, 1, 2, 2, 3, 3, 4. Okay, for the y values, it's 2, 3, 3, 4, 4, 5. 2, 3, 3, 4, 4, 5. 2, 3, 3, 4, 4, 5. No. 5, 5. That's fine. Okay, so now we'll go to Stat, Calc, 4, and calculate. And then regression is 0.88x plus 1.69. Okay, that's y equals. The correlation coefficient isn't here. I'm going to have to pause. My time has run out.